Bismillahirrahmanirrahim. Good morning and welcome to this new video. This is video number 428, and in today's video I am going to estimate feasible generalized nonlinear least squares, that is FGNLS, and I am using Stata for this estimation. Let me tell you the background of this video lecture. Since in today's video I am going to estimate system of nonlinear simultaneous equation system, and the Stata command for this is the NLSUR command, and this command, when used in Stata, fits a system of nonlinear equations by feasible generalized nonlinear least squares, and that is abbreviated as FGNLS. This can be viewed as a nonlinear variant of Zellner's seemingly unrelated regression model, and therefore it is commonly known as nonlinear SUR or nonlinear SURE. SUR is the abbreviated of seemingly unrelated regression, and SURE is the abbreviation of seemingly unrelated regression equation. This model has also been discussed in a number of textbooks, including Davidson and McKinnon and William H. Green. We can have an example of this estimation of nonlinear system of simultaneous equation, and we may think of a situation in which two types of microbes, say bacteria, are placed in a perishable food item, and the population of each type of bacteria are recorded every hour. We may suspect a two-parameter exponential growth model that can be used to model each type of bacteria, but because they shared the same food item, we may allow for correlation in the error terms, that is, the error terms in the two equations may not be independent of each other, they may be interdependent. So we want to fit a system of equation as follows, and the first equation is P1. P1 is the population of type 1 bacteria, and it is given by beta 1 times beta 2 raised to the power t plus epsilon I, where t is the time. And the second equation in this system is P2, that is population 2, and that is equal to gamma 1 plus gamma 2 raised to the power t plus epsilon 2. Epsilon 1 and epsilon 2 are the error terms in the two equations, and they are allowed for having correlation with each other. So we can say P1 and P2 are the two population of the bacteria, and t is the time, and we want to allow for non-zero correlation between epsilon 1 and epsilon 2. We shall estimate this system of nonlinear simultaneous equations by FGNLS. How we can do that? We may use a Stata data file, and I'll show this how to do this, and then I'll explain and interpret this model. So I have already written the command for this, and let me show you the full command. This is the command NLSUR, and then it is followed by the two equation. P1 is equal to beta 1 times beta 2 raised to the power t, and in the second equation P2 is equal to gamma 1, that is G1 times G2 raised to the power t. So by pressing this, if you look at this output, this is the command. The total number of observations is 25, and these are the NLS estimates, these are the iterations, and then we have FGNLS estimates, and there are two iterations here, and there are these are the FGNLS regression equation. This is equation 1, this is equation 2. Now the header in this output of FGNLS shows number of observations, number of parameters, root, mean, square, errors of the residuals, and these are the R squared for the two equations, and since there are no constant in this, so FGNLS has used uncentered R squared. If it if it had identified the constant, then it will have used centered R squared. After this is the output of the regression, and we have the two coefficients beta 1 and beta 2, and then G1 and G2. In our equation, this was beta 1 and this was beta 2, and in equation 2 this was gamma 1 and this was gamma 2. So gamma basically stands for G and beta stands for beta 1. So these are the coefficients, and let me explain this for you. So I copied this output from here, and let me share that with you and I'll explain that. So here is my feasible generalized nonlinear least squares that I just estimated in Stata. So we have, these are the equation level statistics as I mentioned. For P1, the total number of observation 25, two parameters beta 1 and beta 2, root mean square error of the residual, and this is uncentered R squared. There is no constant in this, and then for this we have observations 25, two parameters, and this is root mean square error for the residual of equation 2, and this is uncentered R squared for this equation. And again, the coefficient for beta 1 is 0.39. This is its standard error Z value, and this is the P value. This is highly significant. Similarly, beta 2, this is 1.1195, and its P value also shows highly significant. This is gamma 1 0.51, and this is gamma 2, that is 1.10, and all these coefficients are highly significant. Let me explain this for you. The header, as I mentioned, the header in the output of the regression contained a summary of each equation, including the number of observations and parameters, and the root mean square error of the residual. NLSUR checks to see whether each equation contains a constant term or not. If an equation does contain a constant term, an R squared statistic is presented. If an equation doesn't have a constant term, an uncentered R square is instead reported. As we saw in our model, there was a uncentered R squared that was reported in the header. The R squared value statistic for each equation measures the percentage of variance explained by the nonlinear function and may be useful for descriptive purposes, though it doesn't have the same formal interpretation in the context of FGNLS as it does with the nonlinear least squares estimation. So here the R square statistics is not as it is in case of the least squares, the OLS and other nonlinear least squares estimation, but still it can be used as for descriptive purpose. And as we expected, or as we would expect, both beta 2 and gamma 2 are both greater than 1, and these indicate that the two populations increased in size over time. So that is why they are greater than 1, and you can guess it from here. This is beta 1 that is greater than 1, and this is gamma 2 that is greater than 1, and it means that both these population of bacteria of type 1 and type 2 are increasing over time in size. So ladies and gentlemen, this was a brief introduction and estimation and interpretation of feasible generalized non-least square estimation in Stata. I hope this was quite helpful for you, and for many of you this may be new. Kindly subscribe to the channel, and don't forget to click on the bell icon. Thanks for watching this video. Kindly share the various videos of this channel in various WhatsApp groups. See you in another video. Thanks.